this is a fixed here. It cannot move. So this everything is a ground. Okay, there's a basic diagram which is there. I'm just giving it. Okay, I'll release from rest. The system is released from rest. Now what will happen is asking what will be the angular velocity of the rod when it becomes horizontal. What makes it to be horizontal? You start with this. The electrostatic force will act here. Fe. So under action of this electrostatic force, the rod starts swinging. No? So when we're some arbitrary position, you take it here. So how the electrostatic force, so the electrostatic force acting will be now in this direction. So that electrostatic force which is acting is a constant or variable. It will be a variable force, continuously be varying that one. And by the time when the rod becomes horizontal, what will be the angular velocity of the rod? When it becomes horizontal, this will be the position. How to get this? So shall we take help of torque, because we know how to calculate torque. So shall we apply the torque idea? Yes, you can apply torque. It will be lengthy. Again, you have to depend on integration. Definitely you have to take help of integration. So without any mathematics, can we manage? That's what this question is. Yes. So the angular velocity is asking here, this angular velocity. Can I apply conservation of mechanical energy? Yes, we'll apply conservation of mechanical. So initial, can we apply conservation of, what are the forces that will be acting? The weight. Not visible. I'll take it. Mg, no? So what are the forces that will be doing work on the system? The weight as well as electrostatic force. Even the reaction force will be acting, but the displacement of point of the hinge will be 0. So work done by reaction forces will be 0. So therefore only forces that are doing work are the electrostatic force and the weight. So decrease in gravitational potential G. Mg into 3L by 2. This one. Then initial K 2Q minus Q. 3L plus, this will be 4L, no? This will be, so this everything will become 5L. Three L whole square plus 4L whole square. It should be equal to kinetic energy of the rod. Mass of the rod is how much? M, no? Particle is also having mass. Okay, only mass of the rod. So this will be M into 3L whole square by 3. Moment of inertia, ml square by 3 into omega square by 2. Kinetic energy of the rod plus interaction potential energy. So what is interaction potential will be K 2Q minus Q by L. The problem has become very simple by just applying conservation of mechanical energy. We know all the quantities, just substituting that one, we'll get the omega. Work done by electrostatic force is telling. Work done by electrostatic force, what you should write? Work done by electrostatic force is equal to change in potential energy, you know? So initial kinetic, initial interaction potential energy, how much it is? K 2Q minus Q. It should be equal to minus delta U, no? UF minus UI. So UI minus UF. What is UI? UI will be K 2Q minus Q by 5L minus of K 2Q minus Q by L. This will be the work done by electrostatic force. Work done by electrostatic force, what is the basic formula? Minus delta U. Delta U is final minus initial. So negative of negative. So this will be equal. Substitute UI and UF with sign. I think that's the most easiest way of this one. Say work done by electrostatic force, you can find out by the torque method. I think you really enjoy the mathematics. What happened to FE? The magnitude varies.